By solving the lead code problem, max area of an island. So for this problem, you'll be given a 2D array of size m into n, and this the values will consist of either zeros and 1. So in this grid, 1 represents an island. So you're supposed to find the area of the largest island inside of that grid. So yeah, I think they've already given us a few other constraints. One of them is that the values in the grid, they'll either be 0 or 1. And here 0 represents water and 1 represents the island. So it's a pretty straightforward problem, and we have already solved a similar problem where we had to count the number of islands in a grid. So the logic will be pretty similar. So this problem is categorized as a common Google coding interview question, and the way we could be solving it is we have to traverse the entire grid, and whenever we encounter an island, we need to recursively find all of its neighbors and mark all of them as visited. And that way we can calculate the area of that island, and then we compare it to ensure that that's the maximum area. So yeah, let's try coding the solution. First thing, we'll just create a variable to return them to store the max area. Set it to 0. Yeah, now we'll create 2 for loops to traverse all of the values inside of the grid. So one is I is equal to 0. So this is straightforward. We're just making a grid, traversing down the grid. Next thing we are supposed to do is only if it's an island, then we try visiting it. So if grid, so if grid ij equal to 1, then what we are going to do is we are going to see max equal to or visit island. And for this, we'll pass in the input grid and the value of the row and the column. So yeah, and finally at the end of it, we'll just return the max area. I think I said max area. So yeah, let's try coding the solution for visiting the island. So we'll create a private So yeah, we're now taking in 3 values. One is the actual input grid, and one is the value of the row and the column. So for any solution that involves recursion, there's supposed to be 2 cases. One is the base case, and that's the time we terminate the recursion and we return the solution. Other is the recursive case, and for this case we have to process and then keep calling the same method again. So yeah, for this the base case would be if the value of the row and column, if it reaches a point which is not 1, or if it reaches somewhere outside of the grid, then we stop processing. So we'll add that method. So if I less than 0 or j less than 0, so in this case, it's nothing to process, so we say return 0. Else, first thing we are going to do is, since we have already visited the node, we need to ensure that we mark that cell as visited. So they've already given us a constraint that the value will be either 0 or 1. So the one way we could mark it as visited is set the value to 2. So let's say grid. So this will ensure that when you're recursively calling the method, we don't visit the same cell all over again. So we do that. Then we're going to return 1, since we're already counting the area of the current cell. And then we call all possible combinations. So they've already specified here that it can move in 4 directions. So it can either move up and down or left and right. So we increment I and j and or decrement it and visit all of the neighbors. So I'll just add this. So visit island. So we say I minus 1 comma j. I'm just going to copy this. So here we're going to say increment I plus 1 and j. Here I will remain the same. We'll say j minus 1. So yeah, so we add the current cell and then we add the values of the neighbors. And yeah, we'll do it until we have visited all of the area, and we keep comparing it to ensure that the max area is returned. So yeah, let's try running the solution. Alright, the 2 use cases have passed. We'll try submitting it. So for this solution, the time complexity will be O of m into n, where m is the number of rows and n is the number of columns. Because here you can see we're just traversing down the grid. And then we also have this method where we recursively call all of its neighbors. So since once we mark a cell as visited, we won't be visiting the same cell again. So it'll be like O of m into n plus O of m into n. So it might be, at the worst case, we'll do it twice. But that's still, O of m into n. So that's the runtime time complexity of the solution. Same thing for memory complexity. We are using, so here we are not using any memory area, but since we are using recursion, so that we'll be using stacked memory to store the result of the previous one. So the stacked memory size will also be of O of m into n. So the space complexity will be O of m into n.